3.3 reviews polynomial long division and synthetic division. You have seen both of these things, and so we're just going to do a couple practice of each and then an application using a couple different theorems. So first, long division. Polynomial long division we've been doing for quite a while, ever since intermediate algebra. When you first saw it, you maybe thought, what in the world is this? And then hopefully as you kept working with it, you got a little bit more comfortable, but we'll go through it step by step. So the directions for number one, divide using long division and then use the result to factor the polynomial completely. So we'll do both of those things. Starting with long division on letter A. Long division, remember, is set up with whatever you're dividing by on the outside. And then you get that long division bar, and then you write what you're dividing on the inside. And you want to make sure that you have all of the exponents. If you don't, you need to put a 0 in. So here, we've got x to the third, x squared, x, and then our constant. And so we're good to go here. We don't need to add in any zeros. So we'll finish writing this out. And then when you do your long division, you take the first term divided by the first term. So here we would take the first term, 6x to the third, divided by the first term, 3x. And I'm going to show that work off to the side here. So if we do 6x to the third divided by 3x, that gives us 2x squared. That answer goes as a part of your answer, which goes on top above the x squared that's already there. So there's our 2x squared as a part of our answer. And then we're going to multiply that back to figure out what the remainder is. So if we take this and we multiply it back times both terms, we get 6x to the third, and these two should match, and then negative 4x squared. But when we find the remainder, we need to subtract. So we need to find the difference. So we're going to draw our line and change both signs. Maybe your teacher taught it to you that way and you remember those words, but we need to subtract to find the remainder. So we change the signs that I haven't read. And then what should happen is that your first term should add up to 0. And then our remainder comes from our second term, negative 19x squared plus 4x squared is negative 15x squared. And then go ahead and drop down your next term and start that whole process over again. So we're going to take the first term divided by the first term. So here that would be, use a different color this time. Here that would be negative 15x squared divided by 3x, and that gives us a negative 5x. So negative 5x is the next part of our answer. Again, we're going to multiply that back. So if we multiply back, negative 5x times 3x is negative 15x squared. Negative 5x times negative 2 is a positive 10x. And then when we find the difference, we need to subtract. So I need to change both of these signs here. So then negative 15x squared plus 15x squared is 0. 16x minus 10x is 6x. We've got one more term to drop down, minus 4. And then do that whole process one more time. So we take our first term, 6x divided by our first term, 3x. Here, we get, let's write it up top here, 6x divided by 3x is just a positive 2. So we'd have a positive 2 at the last part of our answer. Multiply that back, right? So positive 2 times 3x is 6x. Positive 2 times negative 2 is a negative 4. To find the remainder, we subtract. So we draw the line and change both signs. And then we end up with 0 here, and we get a remainder of 0. So when we divide the long polynomial starting with the 6x to the third, so when we divide that whole thing by 3x minus 2, this is the answer that we get. Now there's the division, but then the directions also want us to write the polynomial all factored out. And we have partially factored it now because dividing is factoring. So what we did is we said, well, we divided by 3x minus 2, and the answer we got was 2x squared minus 5x plus 2. So we factored out when we divided. We technically factored out the 3x minus 2, and we were left with that 2x squared minus 5x plus 2. Now to factor this completely, I still need to factor out the x squared. So when you have x squared, remember you can do factoring into two binomials and see if that works. Now here we're not solving, so I wouldn't need to use the quadratic formula. I'm not setting this equal to 0. If this did not factor into two sets of parentheses, then I would leave it as this as my answer. Okay, so let's try and factor it, but if it doesn't, that's okay too. We're not solving it any further than this. So if we go ahead and we try and factor this into two sets of parentheses, I'd have 2x and x. Multiply to 2 would have to be 2 times 1. So I'd have to put the 2 off to the side because then 2 times 2 is 4. And then 1 would give us the 5 that's in the middle. Both of them would have to be negative. So that does factor into two sets of parentheses there. And I need to make sure in my final answer then that I also rewrite that 3x minus 2 out front. So my factored answer is these three sets of binomials. So we can use division in order to factor. All right, let's do one more. Same idea. We'll divide and then we'll write the factors out. So here we are dividing by x plus 1. Doing x squared plus 3x plus 5. So again, first divided by first, x squared divided by x. It's going to give us the first part of our answer will be just an x. Multiply that back will give us x squared plus 1x. But then we want to subtract to get our remainder. So that gives us 0 for the x squareds and then 2x for the x values. Drop down the next term and start over. First term divided by first term. So that would be 2x divided by x, which is just a positive 2, so plus 2 on the top. Multiply 2 back, and that'll give you 2x plus 2. Subtract to find your remainder, and that gives us a remainder of 3 because there's nothing else to bring down. So this time, 3 is our remainder, which means our answer then would be plus 3 over x plus 1 because that's what we divided by. So our division is this. Our factor is we had x plus 1. We could break that down when we divided into x plus 2, but then we had that extra plus 3 as our remainder. So that's how we'd write out our factoring.